Welcome back. In the last recording, I avoided telling you how the electric force managed to influence an object without touching it. I came close. I talked about polarization, and what I said was, well, you have some object. I was using a plastic rod and some other object, little pieces of paper, and I said that you end up electrically charging the plastic rod by doing the rubbing thing, and that put a bunch of excess electric charge on the plastic rod. And then when I brought it close to the pieces of paper, the electric force caused the cellulose molecules of the little bits of paper to polarize, that is to say, it caused the electric charges that make up the cellulose molecules to separate in space, either by actually physically moving slightly apart from each other, so changing their orientation, changing their location in space, or causing the molecules to rotate somewhat to align themselves with the force that's acting on them. And so then you had a source charge, you had a test charge, you had the charge on the plastic rod, you had the induced charge, as it's called, on the from the polarized molecules of the bits of paper. And so through Coulomb's law, then you had a force, and then that force then accelerated the bits of paper, which was fine as far as it went. But again, I dodged the question of how did that electric force from the plastic rod to the pieces of paper, how did that force act without physically touching the pieces of paper? As I believe I said in one of the previous recordings, this is new. With one exception, every force that you've ever studied acts only when the two interacting objects, come into physical contact with each other. And so if you're going to apply a tension force on a block sliding up the plane, then you've got to attach the rope physically to the block. The normal force from the plane on the block acts only when the block is physically lying on the inclined plane. And friction happens only when the two surfaces are in physical contact, and so on. The one exception I mentioned is, of course, gravity. The gravitational force on this pen is acting even though the Earth, which is the source of the gravity, the Earth is not physically touching the pen at this moment. Nevertheless, the force happens. And in fact, we can use the gravitational force acting without touching as our model for coming up with an explanation for the mechanism by which the electric force acts. So I'm going to draw you up an analogy, and like all analogies, it's going to be imperfect, and it's always dangerous to take these things too far, but it'll help you wrap your head around it a bit. So, and by the way, this will also give you the opportunity to discover, if I haven't already convinced you of this, of just how bad an artist I am. All right, and so as I'm sure you've guessed by now, this is the surface of a lake. And you know it's the surface of the lake because there's a boat on it. And you know it's a boat because I told you it was. There. Now you know it's a boat. That's how good an artist I am. Right. Now, the boat is over there, and now that I've made it clear that this is water, I'm going to, the surface of a lake, I'm going to redraw it slightly because I have a point that I want to make. And let's decide that it's a nice, calm, beautiful summer day, and so the surface of the water is just nice and flat. Okay. Now, if I were to, presumptively because I want to annoy the person in the boat, if I were to come over here and start whapping on the surface of the water, splashing, pushing down on it. Eventually, you know, if I pushed hard enough and rapidly enough, forcefully enough, I would make some waves, and the water would ripple out from wherever I am. So where am I? I'm over here on the shore. This is me. And again, you know it's me because I labeled it. Otherwise, you might think it was, I don't know, a lollipop or a tent with a sphere on top of it or something. Anyway, so I'm pushing down on the surface of the water, up and down, up and down, up and down, and thus I'm creating waves. And eventually, sooner or later, depending on a number of things that we don't have to care about, sooner or later these waves traveling outward will arrive at the boat. And as soon as that happens, of course, the boat is going to start bobbing up and down as the waves hit it. Okay? I could make the argument that I am applying a force on the boat more or less indirectly, right? And I'm not physically touching the boat, but my activity here is ultimately affecting the boat, ultimately applying a force on the boat, ultimately accelerating the boat in an up and down direction, okay? And so the boat, as I say, will go up and down, and it'll go up and down in time with my my splashing of the water. Okay, so in a very real sense, I have applied a force on the boat over there, even though I didn't come in physical contact with it. However, the requirement for what I am doing to affect the boat is the presence of the water, of course. Take the water away, and I can splash on the surface of the ground, or I can splash in midair all I want, and I will never have an effect on the boat. And so now what I want you to do is focus your attention on the water. Specifically, the water is the medium, the mechanism, the stuff that transmits my influence to the boat. Okay? I am the source of the force that the boat eventually experiences, right? And you can tell how big a force I'm applying. You could, of course, look at me, but you could also look at the boat. And if you knew the mass of the boat, and if you measured the boat's acceleration, then you could infer from that, Newton's second law, how big the force was that was affecting the boat, and therefore how big a force I was applying. Now, with water, of course, there's issues about the waves tend to die out as they go along, but we'll ignore those complications. So I am the source of the force. The boat measures or displays, or the language that we use in physics is that we say that the boat is going to test the force. And so the water was necessary in order for my my force to affect the boat. The water is necessary as the stuff that transports what I am doing to the boat. Okay. So hopefully that seems sensible. But the physical situation is presumptively obvious. But the key concepts that I would want you to focus upon here is that there's a source of the force, there's the thing that experiences the force, which we call the test object, and most importantly, the water holds and in fact is the mechanism for transporting my influence to the boat. Okay? The my force could not affect the boat without the existence of the water. So we think of the water then as the mechanism that transports, the thing that transports my force to the boat. Well, we do exactly the same, we invent exactly the same kind of model for explaining the electric force. What we do is not run over our electric cords as we move the cart. Yeah, dropping pins. Okay, what we do is we say, okay, I think I'd get a wireless microphone, wouldn't you? I had one. It turns out the sound is much better with this thing. So I have an electric charge here, which I will call little q. And I have another electric charge over here. I'll put it over here just to save board space. Yeah, and I'll call this one capital Q. These two, despite what I've drawn, I'm not necessarily assuming that the two charges are the same size. And so then the question is, well, let me identify these. I'm going to more or less arbitrarily, as you'll see, define this one as our source charge. And this one we will call, in the same spirit, our test charge. Okay. And through Coulomb's law, we know that the test charge will experience an electric force from the source charge. It will be repelled. The test charge will be repelled from the source charge, in this case, because they have the same sign charge. Remember, charges that have the same sign repel each other. But how does the influence get from the source charge to the test charge? The answer is we imagine something akin to the water affecting the boat model, is that we imagine that there is some sort of influence that exists everywhere in space, and I will justify the direction of these lines here in a little while. And these lines, whatever these are, and I'm going to tell you in a moment, are created by the source charge. Move this over a little bit. They're created by the source charge, and all these brown lines are equivalent to, analogous to anyway, the water in the lake. So what happened, and the source charge is equivalent to me pushing on the water in the lake. So the model is, the analogy is good, but it's not perfect. So here's how we think about it. We imagine that the source charge generates this phenomenon, this, and I'm going to stop dodging it. The word that we use is electric field. So all these brown lines represent this electric field, which, as I say, is analogous to the water. And the effect, the force that the source charge applies on the test charge is transported from the source to the test by this field, by this stuff in between the source and the test. Much like the water is the thing that transports the force from me to the boat. It exists between us. Now, the analogy, as I say, is not perfect because quite obviously I am not the source of the water, but whatever. I mean, analogies, not identities. Okay. So this stuff here, this so-called electric field, the model that we're going to build and the assumption that we're going to make, and the thing that I want you to imagine, is that the source charge creates this electric field. The electric field spreads out throughout all space, not necessarily uniformly. It depends exactly what how the electric field is distributed in space depends a great deal on the source charge, and we'll be discussing that in future recordings. But whatever the shape of the field is, it's created by the source charge. It exists throughout all of space, and anywhere that there's a test charge within the field, then that test charge is going to experience a force from the source charge, and the force, the influence, is, as I said already 18 times, transported from the source charge to the test charge by this electric field. So the source charge is more or less equivalent or analogous to me pushing in the lake. The test charge is more or less equivalent to the boat on the water, and the electric field is analogous to the water itself. Okay, so there's a great deal more to be said about that, but that's enough for one go. So let me stop there. And what will happen in the next recording is that I'll talk about the details of the field. We'll talk about the fact that the field is a vector, so then we have to worry about direction as well as magnitude, and how to calculate it, and that'll be in the next few recordings.